Hello, welcome and an excellent evening, and we are back with Monkey Island 2 because I wanted to show you a couple more things about how you can draw sprites for adventure games like Monkey Island. Last time we learned how to do screen correct clipping and also scaling and transparency. The IBM PC and the VGA card don't have support for hardware sprites, such as the C64 or the Amiga had, or many other consoles and home computers. So everything had to be done in software by the CPU. This makes it somewhat slower, so to speak. It heavily depends on the CPU speed, how many sprites you can push on the screen. But on the other hand, you can do quite a lot of neat tricks that are harder to do or even impossible with hardware sprites, given certain limitations. And one of those things that are easier to do with a software sprite system is hidden surfaces or hidden objects, basically. If I walk here with Guybrush over this bridge, you can see that part of the bridge is actually in front of him. It's especially visible here behind this pole or post. The face of Guybrush is occluded, but if I walk here, it's very much visible. You can also see which pixels belong to the foreground, so to speak, and which to the background. And things can get even more complicated in other scenes where you can walk behind and in front of objects. Here it's very simple. This is all just foreground, and Guybrush is basically in the background, and then comes the true background layer. But it might happen that you can walk around things. Let's go, for example, into the hotel in this little village, and I think you can possibly walk around here, and then you can also walk more or less, at least partially, in front of this object of this huge mast or whatever that is. And of course you can see a lot of times there is nothing that's hiding Guybrush, but for example here you can walk behind that, but not in front actually. But there is the possibility to go in front of and behind objects. I think the sofa is a good example. Now I'm in front of the sofa and I can go back here, and then suddenly I'm at the back of the sofa, behind the sofa. And how do you do that? Let's close this. Let's take our little scene from the last video, the spitting competition. There are quite a couple of objects, like the tree here that we could imagine that we could walk behind on the pier here. There's this mast with a flag that we can walk behind and in front of. And of course there's stuff like these little sticks and stones, and especially this one here, this larger one, that you could walk behind and also in front of. Also the question is, how do you determine where Guybrush is able to walk? Last time we could just walk up the screen and down the screen with no limits. So there are many ways to implement that. I will show you a rather simple approach today that uses two more images, but you could also do this with polygons that you define. Let me show this. Let's first look at the so-called walkbox, which determines where Guybrush can walk around in this scene. Everything that you see here in green, this is color 254, is where Guybrush is not allowed to walk. I picked 254 because I can give it an arbitrary color. 255 needs to be of high contrast in deluxe paint, so I chose 254 instead. So I gave it this magnificent green here. And you can see this is very similar to the walkable area that we sketched out. For example, this here is the pier, and here's where the houses start. I only roughly drew this, and you can also see that there's a shading happening here. What do I do with the shading? So Everything that is not green is walkable by Guybrush, and the shading actually determines the size of Guybrush's sprite, because we can scale him. So color 0 means that he is full size, and I made a little ramp here up to black where he will get smaller and smaller. And I think I went somewhere up here at the minimum end here so that he gets rather small in the background. And when he comes to the front and walks here, he will get larger. So when we are walking around Guybrush in the scene, we just have to test, is the pixel that we want to walk up to this green color, or 254, then we can't go there. Okay, this is the so-called walkbox, and this is everything that we need from that. Then we need a second thing for the backgrounds and the foregrounds, and I call this just a mask. And it works relatively similar. We have a huge gradient here, or something like a gradient from black to white. And black denotes the background, and the further to the white, or to 255 we get, the more in the foreground we are. This is just because I picked it like that, but you can turn it around and do whatever. It's similar in concept to a Z-buffer on modern graphics cards, and I only selected 2 objects here. This is the large tree in the background, and I didn't even bother to draw the rest of the tree or mask it out. Same with the pole here, the flagpole, because Guybrush can't reach up that high, and I only drew one of the little posts that delimit the thing here. So there you have this thing. These two combined, the walkbox and this mask, will give you the ability to do hidden objects and also define walkable areas for your character. This here works in the following way. We place the sprite, and I'm gonna do it like so. 1 second. Let's pick this here and make this a lighter color, bright white. The sprite looks something like this as a bounding box, and we will pick the point. At the moment it's the bottom right point, and compare this with all the pixels that we encounter here. Here it would draw everything because the scan line that this is on is something like 100, I don't know, can we show that? Probably. Coordinates are here. Coordinates, this is something like line 164. So everything, every pixel that is greater than 164 will be behind us, and everything that will be smaller, 0 is up here, 200 is down here, so everything that is bigger than 164 in color will be in the front of us. So I could draw a shape like this, something like this. And this is color, I don't know, which color is this? This is something way above 240-ish. And this will be actually in the foreground compared to us because we are at 164. And this is obviously darker, so it will be in the background. So if we overlap one of these things, we would definitely be in the foreground. But if we pick a sprite that will be more in the background, something like this, for example, it's not dark enough, but it's higher up, it would be compared against the tree, and it would be hidden by the tree. Especially it will be cut out something like so. Sounds a little bit weird maybe, but it's definitely a very simple comparison comparing to the scan line that we put the sprite on. It actually matters only the bottom scan line because Guybrush is walking on the floor basically of the room, so that is working like that. And that's all the magic. Let's have a look how this looks in the code. We will code a little bit today, not terribly much, because it's actually relatively simple. We will need a new function called check walkbox that determines if the next pixel that we're gonna encounter is walkable or not. And yeah, we also need to load all the data. We do have the background and the sprite sheet already. So we will take all that, copy that, and we will introduce the two new images that we are loading. One is called walkbox, and that is named walkbox.gif. The other is the mask. We're also calling this mask. Okay, that's good. Then we also need to initially check the walkbox to initialize the size of Guybrush. We need to sample the color basically of the walkbox to give him the correct size, otherwise it will jump once you start moving. Check walkbox is the function, and we pass it our walkbox structure or image at position x and y. These are our initial positions, and we actually don't care about the output, so we pass a 0. Actually, no, that's not that. That is the... what did we define this as? The walkbox gets an x and a 0. And a delta x and delta y, because we're not walking right now, it's 0. And we get an output x and y coordinate. This will be the same as x and y if you can't move into a certain direction, so to speak. But you'll see that once we implement that. And a scale that it returns from the walkbox initially. So where were we? We were here. Yes, okay. So we need to pass it x and y. This will just return the same. We could also pass null pointers and check for that, but I didn't do that. And the scale will be initially set. So that is that. Let's have a quick look down here, because I also changed a couple of things here, namely the movement controls WASD. It will now, instead of just walking around, it will do the check walkbox thing with the delta x in the x and y direction respectively, and it also updates the scale factor. So very simple. And of course we have a new algorithm. We have algorithm 5, which is the new algorithm that we still need to implement, put sprite scaled mask. So it will do the sprite scaling with clipping and also apply the mask that we just saw, the Z buffer, so to speak. And then it waits for the retrace and so on and so on. Okay, let's implement the walkbox thing. So checking the walkbox is relatively straightforward. We need a couple of variables. We need a variable for the new x position, the tentative new x position. That's why I call it _nx, because maybe it will be discarded. That is x plus delta x. And same goes for ny, which is the tentative new y position, and that is obviously y plus dy. Then we need a variable that holds our pixel value at this position, so we don't have to look it up all the time. And we will first set nx to x, and we will set ny to y tentatively, and maybe update it in the meantime. If we don't update this, this will be already set to a sensible value, to the old value, so to speak, so we're on the safe side here. Then we do if the tentative new position is outside of the screen bound, so less than 0, and also if the new tentative position is outside the width of the screen, or the walkbox width, so to speak. And same goes for the y, and y is outside of the bounds of the walkbox. Then, of course, we are not going to do anything else, because then we ran really outside of the screen, which is fine, we can do that, but we just return without changing either the scale or the position, so to speak. We can't do anything then. Yes, okay. Otherwise, we sample the walkbox, because we are inside and can pick a sample. That's walkbox data, plus the tentative new position, plus ny times walkbox width. This will pick the position, the pixel at position nx and y. And then we can test for that if the pixel is greater than, and I picked something like 99. So like everything color 100 and above is non-walkable. Very simple. You can adjust that depending on what you want to do, how many scale factors you need, but you don't need more than 100 with our code, because the scaling goes only from 0 to 100. So that should be fine. Everything else should be non-walkable. And if that's not the case, we can actually return the tentative new position as the new position. So that's that, ny equals underscore ny. And of course we can also set the scale factor. And the scale factor is 100 minus the pixel, because I inverted the shading basically. But that's up to you. You can also define it differently. And that is already everything there is. We have this sanity check that we're inside of the walkbox. If we're outside, then we just return, because we can't sample anything and do anything. We don't have any information. Otherwise, we pick the sample, and if the pixel value is greater than 99, it's non-walkable. Otherwise, it's walkable, and it will return the scale and the updated direction, so to speak. Yeah, that should be fine. This is fine. This, of course, only works if delta x and delta y are... Actually, it should work in any case, even if delta x and delta y are both not equal to 0, which we currently can't do. We can only walk like left, right, up, down, and not diagonally. But even that should work. Okay, so I think that is everything that we need to do here. I think we need to switch to the Sprites implementation, and I've already prepared a raw thing here for the like a stub for the put sprite scaled mask. It's the same as put sprite scaled, but it additionally takes another image with a mask inside, and that's that. And it will also be super similar, so we can basically just copy the whole implementation, which is of course always a bit nasty, but the simplest thing that we can do here without resorting to macros or stuff. Sorry. So the only thing that we actually need to do here is to update the test here, because here we have the actual transparency test. Right here, I think. This is the error testing for the interpolation. Then we're looking if we are inside of the VGA buffer, and the star source is testing for the transparency exactly. So that's fine. Let's open some curly braces here, if I can find the key for that. And I think this is exactly what we want. Yes, because we need to sample the mask pixel. So we will have some kind of mask pixel which is equal to something, and we also need to define it. So let's add it somewhere up here. We don't have any byte variables, so I will just call it byte mask pixel. And sampling this is straightforward, I would say. That probably means we take the contents of the mask data, I would hope so, plus whatever our current coordinate is. And I think this is our coordinate, and we should probably put this into a variable of its own. Let's make it an int variable. That should suffice, nx and ny, because these are the new x coordinates that we're having. And we put that right here, I think, where we update our error. So nx equals x minus ex minus 1. And we can also use it here and don't have to recompute it all the time. Very useful, I would say. Same here, and then we will of course also have an ny, and we also need to define that. There should be a semicolon, and y equals y minus ey, something like that. So now we can use it. If mask data plus nx plus ny times mask width, or VGA width, at the moment it's the same. In the future, if you are doing images that are larger than the VGA buffer, then you need to take care of that as well, that you keep track of the size of everything. Plus, then you will have an off-screen buffer that's probably also larger than VGA width or something, but it will take additional memory. You have to check if it fits in conventional memory. But that's a problem for future RAS. At the moment we don't support scrolling or larger buffers. That would also be interesting. Okay, so now the comparison is actually very simple. The Z buffer is actually a Y buffer, so to speak. Y greater than mask pixel. Only then we will draw the target pixel. And I think that might be it. Let's try to build it. We have one error. Oh yes, that of course is incorrect. ny, and let's try to build it again. Success. Let's run it. It is loading, and it is doing something. He's already scaled, and okay, yeah, he can only walk in the walkable area. He will walk over this stuff, but yeah, okay, he's walking behind the post here. And we can walk him to the background. He's scaling automatically, thanks to the walkbox. And he is disappearing behind the flagpole. Let's see if we can walk to the tree. Yes, we can't go on the pier from this side. We need to go around here and a little bit in the background. Okay, here's the here in the mask, or the walkbox is not perfect. You see he can walk up here to the house. It should be more like so. So yeah, drawing these walkboxes is actually a bit of an art. And you can also see here that the mask is not perfect. There's a little bit of ocean shimmering through. Same on the right side. So we could work on that mask as well. But it does work, and Guybrush gets scaled. Maybe you could be a little bit smaller in the background, because actually he's a little bit tall for the houses, right? So yeah, a pixel artist would have to go over that and work pretty decently on this stuff. Okay, we can walk around here. Yeah, that looks quite nice, I would say. All right, pretty decent. I think that is all I can show you today. We are halfway there for a almost playable graphics demo of a 2D adventure game engine, so to speak. There's of course a lot more to do and a lot more refining, and you can see I can even walk out here and come back in. It works still pretty nicely. And now Guybrush also can't walk down here. He gets stuck at the bottom of the screen, which makes sense. There's not a walkable area, so to speak. But he can walk out of here as well. That's nice. All right, cool. Yeah, so that's that. I hope you enjoyed that. Share, like, and subscribe, the usual stuff. Leave a comment if you have any other ideas. How would you implement this problem of occlusion in 2D image-based games? There's, of course, different ways you can do that. You can draw sprites, but that's also relatively expensive if you have to draw sprites all the time. The scaling, how would you do the scaling? How would you define walkboxes with polygons maybe? Are there fast algorithms for like 286s or earlier that can do the tests? Another interesting thing will be pathfinding, to have Guybrush, if you click on the screen, have him walk there using the walkbox as a guidance. That is of course something that the Lucasfilm games also can do. I'm very sure that they probably didn't use pixel-based walkboxes or masks. Maybe the masks, because those are actually have to be pretty precise. And maybe they used sprites even because there's not that much occlusion, and they even have objects in the foreground that scroll differently. They have parallax scrolling, especially, for example, in the first screen of Monkey Island, you have the boat, the little remnant of the boat that scrolls differently from the rest. I think you could do that with sprites pretty easily, but having more than 4 or 5 sprites actually will make a 286 break down already, because the CPU has to do all the stuff. So yeah, I'm interested to hear your approaches. How would you do that? This here will work, but it is a little bit memory intensive. You could probably cut down the size of the mask to not use 256 values per pixel, but maybe only like 4 shades, that you have 4 different layers. But then it will be more difficult to code the comparison, I guess. Then it would be probably easier to just draw additional sprites. Yeah, but that's it for today. You can follow me on Mastodon at chaos.social/@root42. I always read the stuff that's happening there. And other than that, see you in the next video. Bye!